Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at this question that came in the GCE of Further Maths paper 2 in 2017. I don't remember which question number, but let's just solve. Alright, so you have a curve given to you, and you also have some other informations about the curve. So f of x equal to ax squared on ax minus b, and f of x less or equal to 0 as well as greater or equal to 8. So Roman 1 says we should show that x equal to 2 and y equal to x plus 2 are the asymptotes of the curve. Alright, so first of all, I'll try to get the exact equation of this curve. Okay, so I want to define to you guys some basic terms. First of all, minimum value of a function. Minimum value. Now, if m is the minimum value of a function f of x, it therefore means that f of x will always be greater or equal to m. Is it okay? You will always be greater or equal to your minimum value. So you'll be equal to your minimum value as well as you always be greater than it. Now, what about the maximum value of a function? Maximum value. So if maybe n is the maximum value of a function, right, it therefore means that the function will always be less than or equal to its maximum value, because you cannot surpass your maximum value. You can be equal to your maximum value, and as well as you can be less than your maximum value, but you can never be more than your maximum value. So these are the basic definitions. So when you say f of x less than or equal to 0, what does it mean? It means that 0 itself is what? The maximum value. And if you see f of x greater or equal to 8, what does it mean? It means that 8 itself is the minimum value. And we know that generally, if you are the minimum or the maximum, then you are actually a turning point, right? You are a coordinate of the turning point. In this case, 0 is a y coordinate of the turning point, and 8 is also the y coordinate of the turning point. And we know that at turning points, f prime of x is equal to 0. So we are going to differentiate the function, we equate to 0, and try to relate it with this. Okay, so let's find f prime of x. F prime of x will be equal to, we are going to use the quotient rule. We need to differentiate the numerator. We have 2ax. We multiply it with the denominator, and then we subtract from. We now differentiate the denominator. We have a, and we multiply it with the numerator, ax squared, and then we divide everything by the square of the denominator. Okay, so if we simplify all of this, we are going to have here 2a squared x squared minus 2abx, then minus a squared x squared, divided by ax minus b, all that squared. So it therefore means that our f prime of x will be equal to, now 2a squared x squared minus a squared x squared is a squared x squared, then minus 2abx, all divided by that common denominator, ax minus b, all squared. So this will simplify to give us, we can even factorize ax from the numerator. We are going to be left here with ax minus 2b. Yes, I think minus 2b. Then now we divide it by ax minus b, all squared. Okay, so at turning points, what happens is that f prime of x is equal to 0. So if we equate this f prime of x to 0, the denominator will disappear, and we are just going to be left with ax into ax minus 2b equal to 0. Now a cannot be 0, so we can divide both all through by a, and we are going to have x into ax minus 2b equal to 0, which means that x is equal to 0, or ax minus 2b is equal to 0, which means here that x will be equal to 2b divided by a. So those are the x coordinates of the turning points. Okay, x equal to 0 and x equal to 2b on A. So let us find the respective, let's find the y coordinates of that turning point. So the x coordinate, we have x equal to 0, right? So it means that let's find f of 0. F of 0 will give us 0 because we need to replace x with 0 in f of x, right? It therefore means that and also let us use x equal to 2b divided by A. What is f of 2b divided by A? F of 2b divided by A, we have A, we replace x with 2b divided by A, we have to square, then divided by A, we replace x with 2b divided by A, then minus b. So the numerator is going to give us 4b squared, right? All divided by A if we simplify, and the denominator you're going to have here 2b minus b. So in simplifying, the denominator tends to b, and then now the numerator we have 4b squared. The A in the denominator in the numerator will meet the b in the denominator of the denominator. Voila. So this is what we have. Okay, so at the end of the day, we are going to have all of this to be equal to what? I think 4b all divided by A when we simplify. So look at it. F of 0 is equal to 0 and f of 2b on A is equal to 4b on A. Between these two values, which one is bigger? You realize that you realize that if you compare with the fact that f of x is less than or equal to 0, or we have f of x is greater or equal to 8. What does it mean? It means that 0 is the minimum, because 0 is the maximum, right? The maximum. Why what? Why 8 is the minimum turning point, which is the y coordinate. These are the y coordinates. Okay, these are the y coordinates. So you clearly see that we have already had that 0 is what? The maximum. Okay, and it already coincides with this other maximum here. It therefore means that this guy here is going to be what? The minimum. So we just have to equate 4b on A to be equal to 8. All right, so when we equate, that, so let us equate 4b on, because 0 is already equal to 0. All right, so just have now to equate 4b divided by A. We equate it to 8. What does it mean? It means that 4b is equal to 8a. So if I divide both sides by 4, b is going to give me what? 2a. So this is the value of b in terms of A. With that, now we can now replace back into our equation to get f of x, remembering that b is equal to 2a. Okay, so b equal to 2a, right, implies that f of x will be equal to ax squared divided by ax minus, in the place of b, I replace it with 2a. All right, so we can factorize a from the numerator and we factorize a from the denominator. The numerator is going to be x squared and the denominator will be x minus 2. Since a cannot be 0, a cancels, and we are going to have x squared divided by x minus 2. So this is actually our f of x. Now, how do I get the domain? Let's begin with the domain. Okay, so for the domain, this function is a rational function, and for it to be defined, the denominator is not supposed to be 0, since the numerator is already defined. The domain of x squared is real numbers. So for this function here to be defined, our denominator is not supposed to be 0. So f is defined if and only if x minus 2 is not equal to 0, which means that x is not equal to 2. So my domain of f is basically the set of real numbers excluding 2. Yes, that is my domain. But we need to write it as an interval, so we are going to say x is in the interval. If you are not 2, it means that you are any real number excluding 2. So here is the interval notation of the domain. So we now need to find the limit at the bounds. Okay, because we know that clearly from here x equal to 2 is a vertical asymptote, right? But now to do it in a clean way, we know that the vertical asymptote, if x equal to a is a vertical asymptote, it means that, let me write, if x equal to a is a vertical asymptote, it means that the limit as x tends to a of f of x is equal to plus or minus infinity. That is the definition of a vertical asymptote. So if you find the limit as x tends to 2 from below and the limit as x tends to 2 from above, the result will give you plus or minus infinity. One will give you plus infinity, one will give you minus infinity. So in essence, x equal to 2 is a vertical asymptote. Alright, so you have to do that. Now what about y equal to x plus 2 is an asymptote? Alright, so to show that y equal to x plus 2 is an asymptote, then clearly this is actually a slant asymptote, because a slant asymptote is an asymptote in the form mx plus c. Okay, and by definition, if this is an asymptote, it means that if we take the limit as x tends to plus or minus infinity, oh sorry about that, if we take the limit as x tends to plus or minus infinity of the function, that is, we need to take the limit as x tends to plus or minus infinity of f of x minus x plus 2. If it gives us 0, it means that x plus 2 is an oblique asymptote or a slant asymptote. Alright, so let's do it. F of x minus x plus 2 is equal to, our f of x was x squared on x minus 1, then we subtract x plus 2. So if we simplify, the LCM is x minus 1. Here we have x squared minus x plus 2 times x minus 1, which will actually give us x minus 1. Here we have x squared minus, we have x squared minus x minus 2. So this will simplify. We have x minus 1 here. The x squared will cancel. We are going to have let's see, minus x. No, here it's supposed to be plus x. Yes, plus x. So we are going to have minus x minus x minus x plus 2. Yes, this is what we have. Now if you find the limit as x tends to plus or minus infinity, it is giving us minus 1. It's giving us minus 1. It means that there is, oh, okay, no, here was supposed to be x minus 2, right? Here was supposed to be x minus 2. Yes, so here we have x minus 2. Yes, there we have x minus 2. So if we do this perfectly well, this interior here is going to be, that interior is going to be just difference of 2 squares, right? So it's x squared minus 4. So you are going to have 4 divided by x minus 1, and the limit as x tends to plus or minus infinity of that is 0, clearly. So it means that y equal to x plus 2 is an asymptote, and it is basically an oblique asymptote. So in the next video, I am going to be sketching the curve and finding the center of symmetry. But anyways, let me just find the center of symmetry before going, just that my slides are finished. So the center of symmetry is basically the point of intersection of the two asymptotes, that is of the vertical and the slant. So the point of intersection, I just need to replace x with 2 here, okay, so that I'm going to have x equal to 2 and y equal to 4. So that point of symmetry is going to be the point 2, 4. So that's the point of symmetry. So in the next video, I'm going to be sketching the curve, but if you know how to sketch the curve, indicate in the comment section. Thank you guys for watching, and see you in the next video.